All right, the next step in analyzing your data is actually coming up with different methods, right? And so we're going to talk about different methods. So here, the next stage. Now, the logic that you develop is going to help you decide what your method is, right? So the logic that you come up with, whatever the question is, and then what your logic is, will help you choose the method to be able to execute your logic. Now, descriptive statistics as a method, just coming up with descriptive statistics, can tell the decision maker a great deal. However, the next level statistics, right, or the next level methods, can help us see certain relationships. Between measures or between variables, including differences between measures and or measures that predict changes in other measures. Right? You can start, going back to your stats class and going, oh, okay, that sounds like some kind of a model where one measure predicts something else, right? And we'll get into some of that, but we at least want to start building up our methods, simple methods. I don't want to get too crazy with the, highlighting methods and how to do methods in Python. If there's a really complex method, well, the question that you ask will be begging for you to use that method. But let's not just teach you methods in search of a question. Let's make sure we can match the question first and the logic from the question, and then choose the right method that's going to help us. So in this section, we are going to examine mean and standard deviation, and how to use both. To make inferences about different measures. All right, so we're looking at sales for Bibitor. We have a number of stores in this data set with sales of the same product. Beer and wine. What if we wanted to compare two stores' sales to see if the, average sales or weighted average, again, you're always going to be careful with this, if the average sales from one store is different statistically from a second store. Okay, so we're looking at the average, and so we're looking at the means, and we're looking at standard deviations. All right, so let's move forward. All right, first thing, read our data set in. Okay, so this import pandas as PD df equals PD read CSV, right? This should become automatic. It's starting to become automatic for you. Sales final 6302021 dot CSV. You want to make sure that I have the right directory where it's pointing. I want to change I always like changing my sales date. Is equal to pd.to date time df sales date. Okay, beautiful. All right, so we're going to read in our data. I like it. So let's get that in here. Run that cell. All right, so let's take a look at a couple of stores. All right, I'm just randomly chose a couple of stores. So let's look at store 34 and 76. All right, so I first did a query. I first queried the main data set. And pulled just the data for stores 34 and 76. All right, and you'll see that below. I then, I'm kind of articulating my logic here. I then created a grouped variable and used the group for both sales quantity and sales dollars to evaluate the mean, standard deviation, and that's the STD, and standard error. That's the SEM as far as the language is concerned. That's how it's going to be calculated. All right, so that's what I did. So let's actually put the programming in place. So the first thing is I'm going to come up with, I'm going to call df test, and I'm going to go df query, and I want to do this query where store equals both 34 and 76. Okay, so that's going to give me my query. And if I just run that line, I'm going to come up with another data frame. So let's go back to my first data. Here's the big data frame. I'm going to go back to run this line, and I'm going to have a new data frame called df test. And what should be in here, yes, I do want to continue anyway, are all the different sales for stores 34, and I have to go way down, but I'm not going to be able to see it, and 76. So I've just isolated 34 and 76. The next thing I said, all right, I'm going to group all of this data because there's a lot of sales, grouped, and we're going to say df test group by, and what we want to do is we want to group by store. Okay, so I'm going to do that, and then we're going to come up with a summary, df summary. And my DF summary is going to equal grouped sales quantity, oops, sales dollars, and we want to do an aggregate function, and the aggregate function is going to have, I'm going to try this, NP sum, NP mean, NP STD, NP SEM. I think that, I'm going to see if that works, all right? It's not liking that, so I'm going to have to put those in brackets because I have more than one. Let's see if it likes that. Still not liking that. NP sum, what doesn't it like? All right, I got this. All right, make sure I got this right. Grouped, what's it saying? Oh, I know why, because I haven't put in Numpy. So import as NP. Now it does. So I'm going to run that, make sure I've already run pandas. All right, now that should work. Let's see. All right, I'm going to run this, and let's see if I get this DF summary the way I want it to look. It does not like that. Numpy has no attribute SEM. Okay. That was a hope that they would have that. They don't. I can always go into Google and I think I will. Let's go into Google and let's Numpy standard error of the mean. Let's see what it says. All right, standard error, blah, 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 find SciPy, I want to use Numpy. Yeah, see, it's telling me in order to do it, I got to calculate standard deviation and then do another calculation to come up with the standard, to come up with the SEM. I don't think I need to do that, so I'm going to go back to my, I'm not going to use Numpy. What I'm going to do is I'm going to just put in, because in pandas it's already in there, so get rid of all that. Sum, mean, not capital, mean, STD, and SEM. All right, run that, and now I have my DF test, and it should, but that should have grouped by. That's interesting. Oh, DF summary. I don't want that. I want DF summary. All right, so I've got two stores, and I've got my sum, mean, standard deviation, standard error, sum, mean, standard deviation, standard error. All right, so I've got the data that I want to do the test. So from this point, I can calculate the margin of error, right? And plus or minus 2 times the standard of error above and below the mean, and then I'm going to see whether or not these margin of errors, if you will, overlap. All right, so let me just, again, this is all from your stats classes, but now this is an application. Okay, so from this point, we're going to we calculate the margin of error, which is plus or minus 2 times the standard error. Or the SEM. Okay? So plus or minus 2 times the standard error of each of the means. So it's plus or minus the standard error plus or minus the means to see if there is any overlap. And I'm going to perform this test on both measures. both sales quantity and sales dollars. Okay, so let's give me some room here. Okay, so we're gonna kind of do this the long way, and I'm okay with that. All right, so the first thing we want to do is we want to come up with the upper. So DF summary, and this is for sales quantity, comma, upper. All right, so what's going to happen is when I do this, there's going to be a new, under sales quantity, I've got sum, mean, standard deviation, SEM. I'm going to have a new column here that's going to say upper. I'm also going to do the same thing for sales dollars. All right, and that's going to equal my DF summary, sales quantity, comma, mean, plus, I gotta have to do it here, plus 2 times DF summary, gotta put in quotation marks, sales quantity, comma, SEM. Okay, so this is the basic framework of each of these, right? So what I'm gonna do is I'm gonna copy this and paste it. That's gonna be for lower. And I'm also gonna paste it 2 more times for sales dollars. So let's make this lower. And now we're going to subtract 2 times the sales quantity SEM. Over here, we're gonna change this to sales dollars. Copy that, and I'm going to change everything that says sales quantity to sales dollars. And then just to make sure that I get this is going to be lower, and I'm going to subtract. Okay, so that's all I've done. I've created the uppers and the lowers for both sales quantity and sales dollars by taking the mean plus 2 times the standard error, or minus 2 times the standard error to get the lower. All right, so let's run that, and now you're going to see this DF summary transform. All right, now we have 12 variables. So what was what we got? Sales quantity, right? We got our 4 measures, and then over on this side we got the upper and lower sales quantity and upper and lower sales dollars. So now what we can do is we can look at this and figure out whether or not there's any overlap between these 2 groups. So sales quantity between the 2 groups, its upper is 3.34, lower is 3.299. So I'm looking to see whether or not the upper of store 76 overlaps in any way, shape, or form of this, and it doesn't seem to. So that suggests that from a sales quantity standpoint, store 34 is selling more bottles on average for whatever data that we have. Their average bottle size or bottle sales is higher than store 76. And the average sales dollars, remember this is per sales transaction, right? Because we are, or how do we group this? We group this by, we grouped it by store, right? So it's just these stores and what their sales transactions are for the, the mean for these two different stores. So that means all of those transactions, all those 846,000 transactions that are in this data set, we're looking at the average of those 846,000 transactions, right? So that's just a simple test that we did between 2 stores.